Hello, welcome to section 7.1. We're going to talk about linear inequalities. So, when two things are not equal, we call it an inequality. So, what we're going to do throughout this lesson then is talk about if a point is a solution to an inequality. We'll graph them, which is going to be just like when we graphed lines in slope-intercept form, y equals mx plus b. And then we'll do a quick story problem application. With these first ones, it's kind of what you would imagine we would do with this. To determine if a point is a solution to an inequality, I'm going to give you the coordinate, and it's going to work just like when we did like systems of equations. If a coordinate was a solution to a system, it had to satisfy both equations. Well, we're just seeing if a point's a solution to an inequality. So what I'm going to do is take the 2 and substitute that for x, and you take the 3 and you substitute, or the negative 3, and substitute that for y, and you see if it makes it true or false. So if it's a true statement, then it would be a solution. If it's a false statement, it would not be a solution. So in this case, I'm going to take the negative 3, substitute that for y, and I'm going to take the 2 from the coordinate and substitute that for x. And we will see if this comes out to be true. So on the left side, I have my negative 3. Negative 3 times 2 is negative 6. And I'm going to add 8 to that. So you end up with an inequality that says negative 3 is less than or equal to positive 2. So that is true. Negative 3 is definitely less than or equal to negative 2. So what you would say is yes, the point is a solution. And again, there's going to be an infinite number of solutions to these problems because they are inequalities. So multiple points are going to be solutions. Next one. What I'm going to do is the same process. I'm going to take the 2, substitute it in for x, but now this equation is in standard form. It's not going to make much of a difference. Add the negative 3 for the y. So this one I have 8 plus negative 3, and I want to know if that's going to be greater than 10. So 8 plus negative 3 is 5, and 5 is not greater than 10. So that's not true, so you would say not a solution. It's not that there's no solution, like we didn't solve an equation or anything, but what we did is take a point and substitute it into the equation or into the inequality to see if it was a solution. So in that case, 5 is not greater than 10, so that point is not a solution to that inequality. Now we move on to the graphs. So they're going to work very similar to when we graphed, this would have been way back in like chapter 2, we graphed inequalities on a number line, and we would shade things to the left or right. Now we're going to have above or below on a graph. We're going to have the things where when we used to have things, or an inequality, if I had x is greater than 3, we would go on a number line, we would find where 3 is, we'd put an open or closed dot, and we would shade a certain way. We're still going to have that open or closed type concept with having greater than or equal to, or if it's just greater than, or if it's less than or equal to, or less than. So I'll kind of just walk you through in this first example how it'll look. So first thing I'm going to identify, I'm in slope-intercept form. Let's get the slope and the y-intercept. My slope is positive 3 over 2. My y-intercept is negative 1. So now there's a couple things here. We have a greater than sign. What that means is that when we shade our solution, which will be considered a half plane, it's going to be half of the coordinate plane, we're going to call this, we're going to be shading above our line because it's greater than. The greater than or equal to part. So since it has the or equal to part, that means you're going to be using a solid line when you draw it. If this would have just said y is greater than and not greater than or equal to, you would have actually used a dotted line, which means that all the points on the line are not solutions. But since this has the or equal to part, it's going to be a solid line, which means all the points on that line are solutions to the inequality. So to graph this, I'm going to start going down 1 for my y-intercept, move up 3 and to the right 2. So now I have my 2 points. I can connect them with a solid line. That's a really, really crummy line. Just pretend it's straight. And we're going to be shading above that. So what that means, kind of look where it crosses the y-axis. All the values above that are going to be included. So what you do is you shade all of these points. So if you wanted to check to make sure you shaded in the right direction, you could pick a test point. If you wanted to pick any point that's in the shaded region, just like we did on these last examples, you can pick a point and it'll determine if it is a solution to your system or not. Next one, notice that this is in standard form, so I'm going to get it into slope-intercept form, and I also see that I have a negative coefficient to y. So hopefully you remember what happens when you multiply or divide by a negative coefficient with inequalities. So my first thing here, I want to get the whole y part by itself. So let's get rid of this x. So let's subtract 2x on both sides, and that's going to make this go bye-bye. Bring down the negative 3y. Greater than, and I'm going to write this in slope-intercept form, so I'm going to make sure I write the x part first here, negative 2x, and it's a positive 6, so plus 6. Now, we have a negative 3 in front of y. I know that I'm going to have to divide everything by negative 3, but when you multiply or divide by a negative coefficient, you have to flip the inequality. So that is going to become a less than. I have a negative over a negative, so positive 2 over 3 will be my slope. And then I have 6 divided by negative 3, which is negative 2. So I'm going to identify those 4 key characteristics like we just did in the last example. My slope of this is 2 over 3. My y-intercept is negative 2. Since this is a less than, you're going to be shading below for the half plane. And then it's just a less than. It's not less than or equal to. So you are going to be using a dotted line. Or sometimes I'll write a dash. Dash, dotted, same thing. And then we'll just graph this. So we'll start with negative 2, your y-intercept. Move up 2 and to the right 3. You could also go down 2 and to the left 3. It's going to all be on the same line. But notice now I'm going to be connecting these points with a dotted line. What that means is if I were to take any one of these coordinates that are on this line and substitute the x and the y values into this inequality, it would not be true. You would end up with something that would say 6 is greater than 6, and that's not true. If it was 6 is greater than or equal to 6, then that's true. But again, we have a dotted line. We have just the greater than sign, so that means that those points are not solutions to your inequality. So now take a look back down here. I got the y-intercept, I have my slope, I made a dotted line. Now let's shade below this region, which means you're just going to kind of go with the pencil and just shade in this whole area. Again, the points that are in the shaded region are parts of your solution. The points that are not in the shaded region would not work. So you would end up with something up here. If you substituted a point in up here, you would end up with something that would say like 4 is greater than 6, and that's not true. So that's why it is not part of your solution. And then the story problem. Sophia has $2 to buy oranges and apples. Oranges cost 45 cents each. Apples are 25 cents each. So it writes, there's an inequality here, 0.45 times x. That's going to represent the number of oranges plus the 25 cents per the number of apples that she buys. And her budget is $2. So she has to be less than or equal to the $2 on here. So what we're going to do is graph this, and then we'll figure it out if the ordered pair 2, 3 is a solution for the problem. So first thing here, to graph this, I'm going to use intercepts to graph this. I'm in standard form, so I'm going to use intercepts, which means if I want to figure out the x-intercept, I'm going to substitute 0 for y. And if I want to find the y-intercept, I'm going to substitute 0 for x then. So that's what I'm going to do in both of these cases. I'll just write them out right away. So this first inequality, this will drop out. I have 0.45x is less than or equal to 2. So I'm going to divide both sides by 0.45. And this is going to tell me where it's going to cross the axis for the oranges. So what I'm going to do in the calculator is take 2 divided by 0.45. And that's going to tell me 4.44. And then I'm going to do the same thing for the y-intercept. Divide out here 2 divided by the 0.25 on both sides of the inequality. I get y is less than or equal to 8. And what that means is that if she were to buy, if I look at this first one, if she were to buy 0 apples, the maximum number of oranges that she could buy would end up being, this is less than or equal to, would end up being 4. Because I know that if she buys 5, it would end up, if I take 5 times 0.45, it would be $2.25, and she doesn't have that. So the maximum number that she is able to buy is going to be 4. But when we plot this on our axes, it'll actually be 4.44. So I'm going to go right about here, which is between 4 and 5. And again, that's on the orange axis. And then on the apple axis, we're going to go all the way up to 8. Once you have your 2 points, hopefully you remember that with intercepts, I'm going to connect my 2 dots, Holy cow, that is not my line tool that I wanted. Undo. Here's my line tool. Okay, so I make a solid line because it's less than or equal to, and what I'm going to do is shade below this because it's the less than or equal to. And what that means is that all these points in this region are parts of my solution. Now, notice that realistically, I would want to shade this whole area underneath the line. But I want you to imagine right now, why do you think I did not shade that to begin with? If you really want to be correct, you would have to shade what I have for green and blue. But if you think about it, any point in either of these three quadrants is going to represent a negative number of apples or oranges. And we can't have -2 oranges. So that's why I only shaded the information in the first quadrant in blue. But realistically, if you were to shade this inequality, or if you were to graph this inequality, it would be all of this region where my cursor is. That whole half plane would be your solution. So what it says here is the pair 2, 3 a solution for the system? So what that means, first of all, let's talk about this. That means 2 oranges and 3 apples. We want to know if that's a solution to the system. So if it's in the double shaded area, or I'm sorry, if it's in the shaded area, that means that it is a solution. So if I go over 2 and up 3, is this in my shaded region? And it is, so that means that it is a solution. Now, let's show some work to make sure that it is. I know that it is 0.45, it's 45 cents per 1 orange, so she's getting 2 of those, and it's 25 cents. For an apple, she's getting 3 of those, and I want to know if that's less than or equal to $2. So what this is going to do is tell me how much it's going to cost. So 2 oranges, if they're 45 cents a piece and she gets 2 of them, that's going to be 90 cents. And if she gets 3 apples, that's going to be 75 cents. And I want to know, when you add these 2 quantities together, is it less than or equal to 2? So I'm going to take 0.9 plus 0.75, and I get 1.65. And what that means is $1.65 is under her budget, so she actually has money left over. So you would say yes, 2, 3 is a solution. So I know this is a very, very short video, but there's a lot of really crucial information that's in this video that's going to help throughout the entire chapter. So I'm going to go with a recap here. We talked about how we would figure out if a point was a solution to an inequality, which is just like when we substituted a point into an equation to figure out if it was a solution to a system. So we did that. We graphed a linear inequality. We talked about a case where we divided by a negative coefficient to y, and I had to flip the inequality. The whole solid dotted line, and then we went into what a story problem would look like. I graphed this line, which was in standard form. I used intercepts to graph my line, and that would figure out the maximum number of apples and oranges that she could buy separately. And then we figured out, if in purple, if something was actually a solution to our inequality.